Welcome back. So, where to begin? It's been a couple days since I looked at this. I noticed some things a couple days ago, which is why it's been a couple days. And I haven't really looked at it since. But I had some thoughts that I for sure was like, I should probably record this because I was noticing some things. So let's start with what I remember. So I was kind of looking at the Himalayas in this area from this angle mostly. And from my previous research, there's relationship with Lake Baikal and Damodar Kund area here, Kaligandaki Valley. Here's Damodar Kund somewhere. There it is. So, it's like, like, in essence, in order for there to be shallograms over here at the center of the Himalayas, I have concluded that it makes most sense that there's a current flow going into the Himalayas of water, a water-based current flow that was flowing that way. That specifically went across the area of Lake Baikal and between Tarim Basin and whatever this is, through the chakra region, where this is like a lobe and another lobe of a shallogram of an ammonite. Like, say, let's see, maybe, sure, why not? Like this. Lobe, like a lobe. So there's a lobe, and then another lobe, another lobe. This one's a little odd shaped. It's got some prongs over here. But, that's not really that relevant. It's just that's going on in the midst of this. So it kind of gives me an impression there's some kind of current going across into this region. But if it's going across this way, it seems to be related to current going across this way. So what I was thinking was essentially a current is flowing through this region at a southern stretch here visible, and then over here visible, down through here. So essentially some of it went underneath the Himalayas, but some of it went over this way and cut across. So there's a current. This is where it's kind of like backwards. Like there's a current apparently going this way, generally across from Europe, from North America across the top Europe over this way. If you don't know what I'm talking about, see Currents of the Earth or something in the playlist. Evidence of currents, some playlist that I have. With the word current flow evidence. So we're kind of looking at it from that angle. And just for a reference, maybe it would be good to look at them, some of them. So like I have this one, the general current flows, like there's a strongest current going this way, down this way, there's a current going up this way, current coming down this way, current eddying here, current eddying above the Hudson Bay with its center there, where there's all this stuff going on, including this, something of this nature, where there's current flowing across this way to then go to Europe and be like this. Although I've since realized this interior purple, not this purple, but this one, the darker purple, is probably more so this red current going up this way and looping and going back that way. So it probably is actually going the opposite direction here in this purple region. Everything else I still hold to be generally true. So this lavender current up top, this purple current going across, are currents flowing this way, generally speaking, from the Himalayas area. It's essentially a current going this way that runs into resistance over here and bends and goes over this way, like spills out over here, but generally goes more so this way to the Mediterranean, where it then forms an eddy atop Greece, and then goes over here where it interacts with other currents. So just for a little bit of context, so it interacts with these currents. Here's the eddy going across. There's a current that's wrapping around, including South America, generally wrapping around here, wrapping this way and going over, which then interacts with the current over here and here to essentially go to South America and not North America, off of Africa, goes across, and mind you, there's this green current and there's this teal current. The teal current goes lower. The green current, actually, maybe I should have drawn that green, goes up to this boundary here. So the teal current runs into resistance over here and bends and goes back that way and goes over, back around, where then it goes into this loop off of South America. So we got that stuff going on. There's that. There's a current going through Canada, west through British Columbia area, that then goes down past into the United States, into this area towards Yellowstone over here. Goes right to Yellowstone even, passes it, continues on and wobbles in the pressures. It actually deflects at the pressure of the eddy current that was forming above the Great Lakes, which is in this image. So across from here, it deflects. Well, at this point, which then leads it down this way where it feeds in over here and swirls and takes some exit paths and continues over to South America as well. And then there's a current flowing generally out here as well. It's flowing out here and swirling at the Bermuda area. Okay, all that context, because we're looking at Asia, and there's some interesting things I noticed. So, if we look at the Himalayas from this angle, or even like this, it's kind of got like a flat top, and then like a 90-degree bend here, straight. Let's see. Just make it bigger. Put one over that way and one down this way. Pretty close to 90-degree bend. Maybe even a little further out to get this straighter 86-degree bend based on that. There's 90. So it's pretty much in that range. But the point is, if we look over here, I found of interest this. Coming off of this, if we follow it, just continue, there's something like generally this area here is similar, but if we keep going down here, we see this. And then if we go further, we see something else of a similar nature, like coming off it, almost like, almost like there's a current that's going this way around the Himalayas. Like it was trying to go more so this way and down this way, but it got shoved over here. So it went further out this way and bends and goes across this way. Here, over this way. Across. And then it kind of just disappears from Asia, but like it probably interacted here as well. And if we think about like what was adjacent, was really Australia. Possibly over here. It's hard to figure out exactly what was going on outside of Asia, because what I'm talking about is in an Earth expansion framework, not plate tectonics. But I just started looking around, so there's this like string here that's just noteworthy right now. And then there's this, where Lake Baikal has sort of a bend, but if we look over here, there's a similar bend. And if we go out further, here, there's a similar bend that has like a pointed end to it as well over here. And then this boundary going this way has like a width over here. So there's something in this region. It's kind of like how this is. Essentially, what I would interpret this as a region of current flow that was wrapping around here to a degree, but formed mountains and boundaries in ways that are more ammonite-like an end of a structure kind of thing. Over there, at least, a nucleus area. And if we look off here, it looks like this really connects through. And this way, maybe over here. I haven't thought about this with respect to the magnetic anomaly map of the Earth. So mind you, I've interpreted this as undercurrents, but maybe it's not so undercurrent-y, like it's throughout the crust. Undercurrents below the crust is how I initially interpreted it, at the boundary of the mantle crust, but it essentially went up through the crust and onto the surface. I don't think once it reached the surface it necessarily had a major influence on the magnetic anomalies. There's certainly things about the magnetic anomalies that aren't visible in the map itself, but I know Lake Baikal is here, so it looks like possibly to there. It's in this dark spot is basically where Lake Baikal is. So there's this inlet of where current flowed this way down here and divided and went over this way and swirled into the Kursk magnetic anomaly, as well as going along this boundary over this way at a width and across there. And Tarim Basin is here. So here's Tarim Basin. So it goes over and across, basically across Tarim Basin, which is over here. This triangular thing with this little wedge is over here, like right here, generally, in this area. So, according to the undercurrents, there's a current flowing this way that basically reaches this point and divides over here, goes through Tarim Basin out this way. Just across here. as well as other things. Here's the mantle puncture hole that is flow is coming out of in all directions, and then this current flows down towards it, at it really, and causes the inflowing current to divide this way and basically avoid the mantle puncture hole location because of the pressures over here. And that's causing a flow that way and this way. And then there's the ammonite structure, the spiral. There's another spiral, larger spiral here that goes up to the Himalayas, like in this area. So there's a spiral going on here with the mantle puncture hole here. With currents flowing this way and wrapping around, which would indicate that there's probably also currents flowing that I drew flowing around this, wrapping in an eddy here that are actually going this way over here before the earth expanded enough where this is like has the ocean bed that really, like when Antarctica is more so over here and India is like folded in, so there's a current flowing generally across there that's running into this other current flowing across here, possibly contributing to that there's an eddy there, but then deflecting the current to bend it around this way because essentially it goes this way. Is in line, it's parallel with this feature, the end right here. Like it moved up a different energy level, it couldn't get through this way because it was in direct opposition over here in this area, like to current flows across here that led to it basically ramping over this way and then continuing. So it did like a trident type of thing, while other portions were able to deflect and go back this way. So the pressures of the currents were interacting with one another, leading to an offshoot of a current going this way, which then current going this way was encouraged this way to go across Europe underneath the Himalayas south of them and then wrap around in a big like V-U shape thing. A soft bending V or a hard bending U shape. Kind of like shallogram teeth. Like this. Doing something like that. So, what else did I see? I should have recorded right away. It's looking, so that's right. So we have, if we kind of look at this here, straight across with this almost like a button connection, fastener connection, fastener button, like something like this, almost like something like this going on here, where it's physically connecting and having like a tab across it as a result. But this here has this bend to like a flat level, and if we go over here, go across and go back up, here it's doing the same thing, just inverse, and then it's bending inverse to this, going this way. Then it kind of follows the Indonesian archipelago somewhat, but essentially it's very similar, like a mirrored effect here. Here there's definitely a current flowing this way, pushing the Indonesian archipelago and the Southeast Asian islands all getting kind of moved into their final resting place, and relative positions and shapes and structures are all being moved in current flows that we can see in the magnetic anomaly map that basically went this way, ran into resistance and deflected, and then went down this way, down this channel pretty much, where there's these like long like eye-shaped structures in a chain that kind of becomes more subtle back here, but like the arcs themselves are part of it. So there's current going this way, like this current is, this structure itself is current flowing out this way and then creating a V shape flowing this way, which then hits resistance and bends back and takes like a similar shape to what's going on over here kind of thing, just large scale, where then it essentially pushes east to west, and that moves these islands into an arc that then interacts with the Himalayas. Like this has a bend on this end, and then if we follow down to the other side, it's got another bend over here, because essentially there's a current flow going this way, like shooting a fireball kind of thing. Creating maybe like a one of these again, maybe, where it's got like a thinner region where current flows, and then a region where it compiles material in an arc, where over here it did a similar thing, like a smaller region where current flows, and then a region that's over here, maybe not as shaped like that, but still has that same general like arc structure to it. Arcing structure with a backbone spine type thing. So in short, this kind of looks like a chakra, that then from this chakra we see above it this almost like flame looking thing, that then from it has like a light bulb flame looking thing again, and then from it is maybe a smaller one, and then it kind of interacts with other stuff. So my thought was there's a current going this way and a current going this way, which is why this current is bending around, because there's current going this way that's kind of encouraging it down a channel. So it flows that way while there's another current going into the Himalayas, going towards this area to arc it, to make this arc happen. Like if the current flowing this way was not there, it would have probably not exist. The Himalayas would probably not exist as they are, but in essence, it led to this arc happening, participated in the process of the arc happening. Wasn't like the only factor, but one of many that are all interacting. And certainly was pushing into the Himalayas, like similar to over here, where a current is flowing into the Indonesian archipelago region and creating an arc. At the front of the current flow, there's a current going this way into the Himalayas region and creating an arc, while another current is basically applying resistance so that this current abruptly runs into resistance and builds material, and it contributes to particulars arising that are in the Himalayas. I know it's kind of far-fetched sounding if you're like aware of a lot of the details of the Himalayas. For instance, it's layering and its materials and so on. Like water did this, but there's a lot to it. We're just kind of looking at current flows. So like there's one current wrapping around that way that seems to go out this way across, add like a width too. It's generally here, this width. That maybe that current was flowing across, but then it got cut off by a cross current flowing this way above the Himalayas and applying a pressure to the right, which then managed to like stop this process and create a backstop over here. So this current just started to build a wall where it flowed into the wall and pushed its boundaries out, but couldn't actually get through as easily, leading to the end of the Himalayas over here. While that current like went across this way then, and out over here, and down here. Compiling material in the Tibetan Plateau in the meantime. We can also look at it from this angle. Straight edge. I'm trying to think what I saw this angle. I was thinking this current that continues over this way, perhaps was flowing into particularly Western North America, like essentially at this boundary over on the western portion, and then this boundary here. It's hard to see back here, but generally to over here, between this width across, going generally over here to go through here, and going over here, over here, over here, over here, over here, down to where we were looking at, to interact with all the stuff going on here, and then to participate in the Rockies formation. Like maybe this is kind of what I'm thinking, is maybe there was a current that went around this way, continued over this way, went over this way, and when this area, which was actually further up here, like Alaska, the portion that existed was more up here. The portion that wasn't accreted, there's accreted materials, but some of it was up here. Like, maybe I can find a picture. In my downloads folder. I don't know about this. Not looking good. I don't see anything. Say something like that. Oh. There's gotta be some terminology, maybe Precambrian map. It's alright. I'm pretty sure it was over here. But then it moved. Like, rotated outward as this rotated outward. And they became attached to one another at different energy chakra points. Like, they physically reattach energetically through chakra structures. But in so doing, this current over here was able to flow this way and then flowed into here, I'm thinking. Because it's kind of coming at a weird angle. It's coming in up from over here for sure. It's definitely coming in over here in like a generally this way. So it has to be coming this way. I thought maybe what was happening was it was up here and current was flowing like this way into here, down this way. This is a big part of my research also with regard to Baja BC data and things, where there's an actual, there's a major aspect of the Earth's history that is in this area that can be only really meet the observations with a completely different model than present models. Plate tectonics cannot handle the evidence there, but I've linked many things like the relationship of this area, which is near Fiji here, where there's this magnetic anomaly structure, these paths, and their relationship to the area, their relationship to over here, to the over here, so many things that I've related to this area in ways like Ontong Java Plateau, Hikarangi and Manihiki Plateaus. Ontong Java is here. These ones were all formed together and are all intertwined with the process of this area forming. But that's really related to accretion of new materials over here. So there's pressure, there's currents flowing over here, pushing physical land masses into this area that are then being swept by water currents from somewhere. And I was thinking up here, like flowing in here. But really this flow that probably was happening from this direction, coming in right here, creating this like chakra point, essentially ran into resistance and went around it, and then goes over this way and down. So it's almost like a current went this way and went around, and that current, as well as the pressure over here pushing into that current, and another current flowing in this way that went down through here, interacted in the creation of the Rockies, as well as that current continued over here and made the laramide orogeny over here. So I think like there's some merit to that current based on its shape structure, the structure of this current. That definitely comes in at a boundary generally over here. And just above it in this area. In this way. Generally across here. And down through here. And has an upper boundary that comes in over here. Goes across. Across there. And then across here where it like deflects. There's this region of interaction where this current actually goes straight into this area, but then it's basically across from the Hudson Bay where there's the center of this eddy. So if you imagine an eddy and there's a current flow pushing into it at the very top of the eddy, there's only the very top of the eddy's width to deal with to the side, but as it approaches the nucleus of the eddy, the center of the eddy. In order to push into it, there's the entire width of the eddy that it's pushing into. So basically, at that point, it leads to an interaction where this system applies a pressure out here, and it actually is able to interact with this cross current over here, allowing it to get out here as well as exchange to happen. But then it bends this path, so it's not going at this angle anymore. It actually starts going at a different angle down here. Like it bends it and goes down this way, and then it branches off down here into like fingers, like a dendritic current flow that then interacted with all of the flooding in this area, causing it basically. But like, I didn't really know where exactly the water's coming from. I think it kind of makes sense that it was physically flowing across this way and up here. Any water that was going through this channel before this stop happened was continued to flow over here through this region and through this region, basically through the center, and then through the center, and then through this, and then just over there. Maybe before this open though, it was more able to flow along a boundary even, maybe. So it ended up going more so along this boundary and through here, flowing out in this area maybe, more so, like out this way. And then across into Alaska. Let's see some other things. Some other things. So if that's the case, just a heads up, just if that's the case, there should be some evidence of weirdly positioned zircon grains, detrital zircons, along this path, even in the Rockies, in this area, that are really have some affinity, some relationship that's a little oddly too related to over in this region, where that happens with the Appalachians. The Appalachians have grains all over here. The entire Navajo sandstone is Appalachian grains. There's many examples of Appalachian grains, like up here. I think it's over here, somewhere in this general area, some sand dunes or something or other, or oil place of high oil content. But over here, there's a bunch of Appalachian sand grains, but they're just like across the country. They're pretty far, like 1,000+ miles, but they're not like from over here and found over here. That's significantly further. And that doesn't mean it's not the case though. Like, it might be something that's like observable, is my point. Mind you, the Himalayas formed really after this stuff was largely underway. So it's highly likely that the formation of the Himalayas didn't really get influenced by these currents until later on, and besides just like accumulating material maybe. But like once it really started to stop the process here, there was a lot of pressure going on, which began after the Rockies. So it's probably the stopping of this where a current flowed across more freely and out over here where a current was blocking it by going this way, allowing it to vent out over here. Probably played a major part in the nuances of the Himalayas. So I wouldn't expect Himalayan grains to be found over here. I would expect earlier aged grains like the Punjab traps or something. Punjabi traps, maybe that one. Nope. Panjal traps, the emission traps. So like, let's say if we just go zircon grains, emission, large igneous province, and then try to look for anything not talking about that location. Maybe add, why not add some just Rockies. China, Tibet, North America. Nothing immediately popping up, just seeing if there was any, like, paper on the Rockies that mentions, let's say, Rockies, detrital zircon, Asia. So there's like all the key plutonic assemblages of the Appalachian orogeny. Blah blah blah. This is unreadable without turning off dark mode. Let's just see Asia. I think it was just saying something in passing about Asia, modern mountain belts of Central Asia. Texas, we got some Appalachian, Grenville, zircons. It may be very far away to a point where it's hard to even find anyone comparing them, honestly, as well as like the lack of study in that region relatively. Like, people are gonna tend to say this zircon is reminiscent of this other zircon that's closer by than Asia. Especially when the data on detrital zircons in this area is probably just less accumulated and segmented. Like, it's not the same people doing it. They're just going to be less aware of the alternative points of origin, so they might not really reference it. Be optimal to see someone just being like, yeah, this looks like the one from over in that area, and really only looks like it could be that one for some reason. Sandstone cobbles from the lower Chagan Hebu are characterized by Grenville origin sources and resemble the Upper Bayan Obo group in North China Craton. Major Southeastern Central Asia. I don't wanna. Okay, fine. I guess I gotta view the PDF. Central Asian orogenic belt is one of the Earth's largest accretionary orogenic belts. Formed by the accretion and collision of diverse oceanic island arcs, seamounts, terrains, and microcontinents as a result of the subduction and closure of the Paleo-Asian Ocean. Terrains or microcontinents that contain Archean to Neoproterozoic continental crust and Paleozoic archmagmatic rocks represent rigid blocks in the Paleo-Asian Ocean. North China Craton. Okay, that's China. Needles in a haystack. Detrital zircon ages in the maximum deposition age of modern global sediment. This study uses a global compilation of 70,000 plus detrital zircon uranium-lead ages from 792 modern and Holocene sediment samples to evaluate the frequency with which various maximum depositional age methods approximate the total depositional age, and approximately 0 million, and to determine the geological factors that control the global distribution of Earth's youngest detrital zircon. We show that young, less than 2 million, zircon are rare, interesting, and are largely restricted to areas associated with active volcanism. Dilution of the youngest volcanically sourced grains may preferentially occur in large sediment routing systems, causing the youngest grains to be missed during routine provenance analysis. Methods of calculating the MDA that rely on just 1 or 2 grains yield results that are closest to the TDA in the modern Holocene dataset. However, the use of more conservative MDA methods that rely on multiple overlapping age measurements are likely necessary for avoiding calculation of an MDA that is younger than the TDA in ancient samples. A number of strategies can be used to increase the likelihood of finding young grains, if present, including conservative mineral separation, blah, 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 blah. It's just kind of interesting that there's a lack of zircons at a younger age. Almost like they aren't really being produced anymore. Except active volcanoes, I guess. Kind of points to that the process has materially changed across time, and it's not just plate tectonics. Plate tectonics forever. Always the same slow and steady processes. No, the Earth expanded in the global flood. That's not happening anymore. That's why detrital zircons are basically non-existent in more recent times, according to what I see there. I don't see anything talking about North America. Pardon me. I know sometimes it just kind of slows down if I do stuff like this. Especially if I'm not really looking at like the details and just not reading what the words I'm reading like aloud. The paper presents something. Age data on detrital zircons from sands of major Russian rivers. Obtained data are discussed in terms of major episodes of granitic magmatism, which are recorded in the continental blocks that form the modern Eurasian continent. Results are compared with published igneous and detrital zircon age data obtained from parental and sedimentary rocks of the river basins under consideration and worldwide. The uranium-lead age results allowed us to confirm 1. The episodic character of continent formation, the Neo-Archean global magmatic event, and possibly formation of the Kenorland supercontinent. The global episode of crust formation at this time, 2 billion to 1.8 billion, which formed the Columbia supercontinent. The breakup of Columbia, 1.3 to 1.2. The major period of Phanerozoic crustal growth in Central Asia, likely to be the result of the Altaid orogeny. On the other hand, our data did not unambiguously confirm previous idea about the global character of the Grenvillian and Pan-African orogenies as a result of the assembly of Rodinia and Gondwana, respectively. Rodinia peak is not observed in the histograms of these places, whereas the Gondwana signature is not obvious in the histograms of these other places. Of special interest are these peaks in the something zircon age. Oh, that's the place. Spectrum. In spite of the absence of so far identified Archean and Paleoproterozoic parental rocks in the Obe catchment area, the obtained age spectra were joined into 3 groups based on statistics. For future reconstructions, we suggest to include blah blah. Okay, let's just kind of glance. Mainly because this might help us consider current flow paths. Western Siberia, Siberian Craton, Lake Baikal. Overlap continental margin arc. Transform continental margin arc. So around Lake Baikal, there's a overlap continental margin arc. Some data. Data. Bunch of text. Okay. Okay, pretty much the same thing in their conclusions as the abstract. So if we kind of follow this way to here and then here, there's also this shape that kind of suggests maybe it bends also this way. Like at this width and this width. It goes over here. Seemingly running into resistance, I guess, and then going more so this way. Although it's a little odd, like this here. What is going on? Because essentially, my thoughts are there's a current that must have gone generally to the west of this like shape here and gone across here to Lake Baikal. Maybe bending a bit along its path, even not just traveling in a straight line. And then it continued over to the Himalayas. So maybe like generally here. Or some of it went over here and held a boundary. But then that would suggest there's current going into this boundary over here. Because I was thinking this is going this way. And then over here is going this way and bending. Which maybe it runs into this and kind of flows back. These aren't that tall. The water was probably above this level anyway. So it's still going across it freely. Just with some restriction at lower depths or higher depths or whatever. Lower down. Closer to the surface of the earth. The depth of the water was interacting with mountains and things of that nature. But because it was so deep, it would still go over top the mountains, especially relatively minor ones compared to their surroundings. Like this is like 1,000 meters above the surroundings. I'd say 2,000 even at most. It's really not that much compared to other mountains. 2,000. It's probably not even mountains. Just big regions of hills, practically. So if there's a current flowing this way that's running into a current that's going in here, and maybe going across this way. Like it must be interacting, a current coming this way, interacting with a cross current here that's vibrating the current out into this like It's very similar in shape to what's going on here. From down here up to here, this like widening to like a boundary and then narrowing like a top, like a spinning top shape. Very similar shape there to here. And here there's definitely a cross current involved in making the Mariana Trench. It's a current coming this way, but there's another cross current flowing over this way, like from over here, down this way, over and around, across specifically here. However exactly it gets there, over here is less clear, but across here to here, where then it continues over this way, through this area, across to the base of the Mariana Trench, the southern point, as well as the top having this one, this boundary, if we follow over this way, through here, through there, where this yellow is. Or no, is that? This one's just harder to see. I think here. I'm not sure anymore. Why am I not? This one's still visible. Especially in that area. This one I think is most visible back here. But essentially there's a current flow here through this area that goes across and pushes out the boundary here to make the Mariana Trench, interacting with a cross current though. So there's currents running into each other. One's going and another is pushing its boundary out pretty much, while inducing a similar effect on both sides. It doesn't just push the boundary out, it mirrors the effect across in like up down kind of ways as well. Like this is probably, it's maybe taller. Let's see. It's even got a path through here. Look at its far boundary. It's got a separated path, kind of like the Rockies. So there's probably a current coming across this way. Generally from over here going across. Like through this area. And then above this. Like above the entire structure here. And across this way where it kind of reaches that point. And then pushes the boundaries out. It creates this top spinning top shape. And then makes it kind of bigger over here and have like different tiers to it kind of thing going on. And then it just, the current continues. But I guess Lake Baikal had a current going this way. It looks like there was a current going this way across, and these currents interacted, and that led to a current that was going this way to arc a little bit, like take this shape, but also to go down underneath this cross current that's going this way, I guess. Just based on this boundary, more so going here and out this out this way. Kind of interacting here for that boundary, interacting over here for that boundary, and then interacting in this region, starting from the tip of this spinning top, just past it where this candle flame light bulb looking thing, weirdly shaped light bulb with some kind of steps to it, had a cross current going this way and interacted with it again. So this current went across, but then had that interaction, had this interaction. Maybe it's more like arms of a galaxy even. Where there's like a flow from the nucleus, from the northern terminal here. Like physical spiral arms that were most apparent over here. Like this is so close to it, so it almost looks like it just right off of it, but it's as we get further away, maybe it goes more sideways this way, and maybe wrapped around here into this area, and then funneled through here too to go across. Kind of held this space while another current generally went through this whole area. And maybe like had a boundary here and a boundary here where it kind of funneled through this area and over here, but like turned over here through the Tarim Basin area. And maybe also interacted there. Almost looks like this is related to the Himalayas. There, so maybe any current through here really went over here more so and wrapped around there. Possibly went across too, like just straight across here. It's kind of odd, like the Indonesian archipelago is kind of held up here, like it was running into resistance. Maybe part of the resistance it was running into was like a sturdy band of current flow on the surface that was flowing across here, that then went across here. I don't know. I feel like I saw some other things. I'm just struggling to remember now. It's like, dude, this alone is sick. With this thing going on here. Hmm. It may be that this area is actually more so from over here, going this way into it, and then over here was more related to the bottom segment, creating an actual divide between them, like an area that got compressed, where more material got compiled there. I don't know if that's... It looks pretty similar elevation-wise. Like the color is not indicating a higher elevation necessarily. Certainly a tendency, but some of them have not been. Maybe. It does look like it connects over here, through here to this area. Chingaga. Also kind of like a fastener thing going on there on the top, pointing pretty much where those current flows are coming from, just above the mantle puncture hole, a little to the east. But at the end of the Himalayas, there's a tab. Here, I mean, it's pretty centered. Here's Tarim Basin. I can open some animations, I guess. Maybe this one a little higher. Like that. Some broken bonds here. Australia was attached out here. Oh yeah, also, if we put this down and kind of look at this width and just follow it up, this boundary is very in line. And it bends, interestingly. And then if we go over here, like this edge at least, is very much in line. Using this thing as like a flat surface, like there, and going up along this boundary. Like the tip of India is right in that length. And then maybe even some relationship over here. I'm just trying to make a straight line through this area and kind of see what it points at. Like if we go to the center of the Indonesian archipelago here, wherever the center is. Certainly seems closely related to how far that is westward. Like a boundary current flow was holding resistance. And then similarly, if we kind of go to the base, right here, across. Relatively related to where Southeast Asia's like boundaries are. I don't know, just kind of checking it out at that point. Probably some kind of relationship too. So there's current flowing this way and wrapping around. Other current flowing down this way through it. current going up past it though, to the east of it. A dividing current going through here that divides some of it over this way, so it can't like connect back to over here, so it flows this way. Really points to like the boundary of this thing, this side. Following along this general path. I don't know how good that path is to use, but there's some complexities in this area, that's for sure. Currents going every which way, interacting with one another. Kind of like air currents. If we go to high up, there's certain ways, and then like they're going generally east to west at the equator, doing some stuff over here. But then they're changing. Is this air? Says air. It looks like water currents. There we go. I don't know. Whoa. But if we look at different places, like it's not even the same. Just totally different. This is what I was getting at. Things of this nature are happening in the water currents that were flowing on the surface of the earth. Like the air currents now tend to flow in layers, some going different directions at different layers in the same physical like coordinate location. Like actual layers of different direction of current that then interacted with one another and led to mounds building up, or eddies, and all sorts of complex outcomes depending on the circumstances, and just shaped the earth entirely, creating the structure we now see. Whereas over here, there's just currents going every which way that really need to be accounted for to like really document how this area was shaped. And anything that I present is going to be an approximation. It's going to be based on X, Y, Z. It's not going to account for this other variable, and that's going to add some other nuances. That's just how reality is. I imagine we could do it pretty thoroughly, though, to a point where it's like, okay, What are we missing? Like a general boundary here. Would definitely be suggestive of a current flowing west to east. Where exactly its source is from, unclear. Maybe from up here, like flowing out this way and over here, running into resistance over here, interacting more at this location, where it's more able to freely flow over here. But maybe also pressures over here flowing and kind of conjoining here, flowing over, like extending out this way from here and here, going across, as well as maybe a more, like, I drew it before, current going across this way. That just flows over and interacts down here as well, but like there's certainly pressure pushing in over here, but then there's like exhaust of a lobe sticking out and holding space. Some kind of basin that was just filled with water, creating its boundaries. Probably because current's flowing this way through it. Current's flowing this way through it, as well as kind of bending. And current's flowing the other way through it and this way, because it's almost like in a pinched area where there's pressure from all sides. So there was like this region where current could compile in an eddy and an actual boundary shaped. But it wasn't stable, I guess. So it drained out once the process was done, leaving behind just its boundaries and a decaying sea. Like this sea was, even in human history, was much larger and is drained out substantially. Circular feature there. I'll probably talk about shallograms again in the next one. I found some cool shallograms, that's for sure. Like, I almost did a shallogram video just because it's safer. It's easier. I can just talk about shallograms for sure. This kind of stuff is more, we'll see what happens. Smack. Unless I'm more prepared. Also, I started writing a book. I wasn't sure if I wanted to tell people because I don't want to... I've started writing several books. There's a difference between starting writing a book and writing a book. But it's on shallograms thus far. We'll see how it goes. I'm like 20 pages in. I'm probably not going to sell it because it's going to contain images of shallograms. I really can't sell it at that point without permission from the picture takers, or to take my own pictures only. I don't have enough shallograms. Like, I would need to buy every shallogram I want to put in a book to then take my own pictures of them and put them myself. It would take thousands of dollars. Perhaps even tens of thousands. I mean, I certainly, with thousands of dollars, could do it, but then just use the ones I could get. But, that's a little unreasonable. I'd rather just be like, I guess I'll just publish it freely as a PDF and call it a day. It's a little hard to convince people of its importance at that point, though. That's the problem. Can't sell it because that would A, be rude, and ultimately would need permission of the... I could potentially get like 3 people's permission, and most of them would be covered, and then just not use anything else. But I don't know. The point is, I started it, and I got something like 5,000 or 6,000 words. It's like, how many words per page book? Say a book. 40,000 words would be about 130 pages. $60,000 for, so basically 300 pages, or 300 words a page. So I'm around 20 pages of text. Bunch of images though, so it's like 35 pages because of the images. And it's not gonna stop having images, so it's probably gonna be, if I keep going, it's probably gonna be a pretty long book. I don't know how to do it exactly. I just started writing. I was like, maybe I could just show it real quick. I know those tabs are brutal. 37 pages. It's also not like fully written. Like, more detail. Comma, end of sentence. Comma. But I quickly get into a proposal is made that they cannot be fossils, shallograms, but instead can only be the result of having their surface and structure shaped by highly pressurized water currents. Kind of like we were just talking about. Literally, that's how epic shallograms are, is they are the same thing fractally that happened to the Earth. The question, why does it matter, is worth answering. In short, because it is the case. They're not fossils, do not contain fossils, because they cannot. So I really want to like go into, I need to label pictures. So like, this is Rudrox Guru. I could ask them. I don't know if they'd be down. This is Rudrox Guru. A bunch of them are Rudrox Guru. I don't know who this is from. So I'm kind of just discussing the common features like the opening, the mass that can form there and have like features of an ammonite, the teeth, the lobe, it's, as I call it, the lobe, the nucleus, the chakra, the other chakra, the pair of chakras, the overall ammonite structure, maybe some other terms, but then sutures, and I'm just like, these things are all features of shallograms, and I'm saying these are the result of current flows, here's why, kind of thing. So then I just started putting in some pictures, writing. Feel free to pause, I guess, and read what I have wrote if you're interested, since I'm scrolling through. Like, this is how bad it is right now. Also, I need to change the font, change the structure of the paragraph, make it not spaced, and maybe change the spacing in general, all sorts of things. This one, where what I'm really doing is trying to present like details of the process by, here's an example, so I'm not really talking about this shallogram, I'm not really talking about this shallogram, at least not yet. This one, I'm not really looking at like the full scope of its details. More so, I'm just like, look at this feature. Sometimes they're rounded, other times they're elongated and tend to have a single ammonite in the elongated rock like this, the flattened rock, where the ammonite tends to be along its flattened direction. And then I'm like, well, here's generally what happens. Sometimes the current will create a flat face. That flat face can be etched by the current further to create a dendritic face like this. And other times it can be etched so much so that the material is just gone and a void exists. But then it doesn't quite get into the nucleus as easily, so it can leave an ammonite structure internally as well. So there's like an external one and then a nucleus internal one. And I'm not talking about the totality of why this shallogram is epic. This one is very important, these things. So I talk about them and how they occur by like pressures outward meeting each other and extending out this way, as well as top and bottom, and then 1/3, 2/3 positions. Here's another example because it's important to know this is not just like a singular time. This happens repetitively. Here it is again off the top and off the top positions, but this one wraps around in a weird way where the currents physically collided and branched off into this stream here. Don't even make mention of the other features, because that's not what I'm doing. I'm just trying to explain step by step what I think is happening and to paint a picture, and then maybe later on I'll more focusedly choose like a few shallograms to really go into detail about. If I write this book, in the least, I'm scrolling through equatorial belt, so this is relevant. This one is like, dudes, what are we doing? It literally wraps around to become a suture pattern, and then continues through some pseudo chakras, and then conjoins back to the other side, fully wrapping around the rock, having a suture pattern out of this wave. Doesn't even make sense. These are ammonite features, but not in ammonite. Like, there's no ammonite that looks like this. It's even got the suture patterns internally here and over here, like in this region, in a way that doesn't make sense, as well as down here. But like, this doesn't even make sense. They're not in the appropriate positions, but they're clearly part of the structure. Like, they can't be separated, just as this wave can't be separated from the suture pattern. But it really distinguishes they're not fossils. Here's this one, which I commonly bring up. The two ammonites conjoined in a way that two shells cannot. Another one where it's bending, literally bending. Like, there's, it's hard to put in more than like one picture without a trade-off of them being smaller, so I didn't put in another image that shows the actual, like, this stuff, like the ribs of an ammonite going back this way. It's not in this plane though, but it obviously starts at this chakra, starts at this base, and goes up and goes in a different plane, which an eddy could do if it's like contained in a weird space where it bends. But a fossil, then we gotta start making up new species. That's the only way. Oh, well, there was this time, which is true, there was some weird shaped ammonites, but that's because they were in weird conditions that weren't regular, that were more like this kind of circumstance where it actually had to bend the actual eddy structure in a way that it then just is some random coil that flows in a weird way, but really is because of circumstances. And it isn't an entirely different species because these never were living creatures, that's the point. And this one, just to kind of show the little rib extension, the current paths on the surface that aren't in the same direction. Like, if this rock was in a river and water is flowing atop it, they would, if it's etching it, it would etch generally along the direction of the current flow. It would not etch along the direction of the ammonite. Like, it's going in this direction. It's going in this direction. It's going down here in a downward direction, although it's really subtle and not even visible in this image. And then up here, it's going that way. Like, it's actually bending. And maybe up here in the lighter area, it's bending that way even. It's actually bending around the stone, which doesn't really make sense. And then this one, which has a chakra here. I try not to insert any images with writing on top of them unless I'm pointing to things I haven't done yet, and that I'm probably gonna do if I really finish this entirely. I'll probably do that. This one that has the physically two overlapping ammonites again, that just can't be. It just can't be. This one with this ammonite inside, like, that even bends to the shape of the contours of this rib indentation from here to over here. It's within the boundaries. Like, it formed in a container of this upper wall pressure, and these two walls have formed up here at this boundary. And then it has this path over here. It's not that visible in this image. I do have this one, so I could probably use my own images for this one. This one that I'm talking about, the current flow of the grains of material that loop basically go through the chakra down into a base that then compiles material, but then the pressures from all directions but downward, the pressure from downward causes the flow to physically cycle back to the top, which ends up forming a conduit, a channel that cycles back to the top, this material from the base, and forms an actual conduit that connects back to the top, and then it drains back through, and this process continues, which then differentiates the material to make pyrite make the ammonite composed of not just black shale, whereas the rest of the stone tends to be more composed of just black shale. Because of this differentiation that occurs as a result of the process. Like, this shape is not normal, is my point in this, essentially. And then I'm saying, okay, sometimes the drain physically cuts off. Like, this mound is not connected to the chakras, but the drain, it's still going through here. The process didn't stop just because this material stopped going to the top. It just basically removes enough that it flows past the mound. Water flows at that point, not shale, but just water, down this drain, through it, and starts to etch out the material at that point, where then the top gets etched. And here's another one where the drainage aspect of it is really evident, and another one. And then here's an example of the top, and how this one probably could use some labels, how it segments into different structures as a result of how the currents interact with one another. This one, and then I started, I don't think I really wrote any more on this, but started to talk about how it has these like drill marks. Like, here's one like this. So I just kind of put some of the images together, and then a little bit about pyrite I didn't finish writing, and a bunch of pages of some just images that I figured I'd use that about pyrite. This one as well, and then talking about pseudo fossils, so I'd probably want to move that. And then some other images I was gonna put in there. I didn't really plan on talking about my the book I was writing, but let's see. Tools. How we doing? Oh, okay. Certainly some wasted words, but and some missing words. So I could for sure do this. I could for sure write an entire book on just shallograms, but I could also write an entire book that starts with just shallograms and then starts to expand into geology, where it's like, okay, guess what? These aren't just on shallograms. These same features are here. Large scale, larger scale, larger scale. Look at how they're all over the place. Now that you see these shallogram features, see how they're also over here. And because we know the shallograms are formed by current flows, we can quickly extrapolate over there and be like, well, that actually corroborates, first of all, that shallograms are caused by current flows. And it also makes sense in view of the shallograms, like what we were talking about earlier, in terms of Asia and so on. Like, there's things going on the surface of the earth that can better be understood through the lens of shallograms. So it might actually be just like a good first part of a book. Like, I could feasibly write a first part about shallograms, a second part about geology. I don't know if I want to do all that. Just sharing some things that have been on my mind lately. Well, stuff's going on here at home. That's not so good, but yeah. Started writing this like 4 days ago. So, mind you, this is like 4 days of work. And probably like half of that spent writing at all. And then half of that still spent focusedly writing. So probably only spent like 2 days really putting much of time into this book. I just hope to continue, because I think it's a good idea for sure. First of all, that I write something more complete. At this point, I could probably do it. And I noticed, like, once I started doing it, I can really just fall into like, for instance, I'm talking about this indentation and how it doesn't really make sense for a shell to have been inside here and then the rock to have solidified in some way for it to then be indented. Like, it's clearly something pushed into the rock and bent the material and indented into the space of the ammonite. I don't know how true what I say is here. I think it's kind of reasonable, but I think also people who believe them to be fossils will have counterpoints to the concept that if there's this like indentation into the soft material, then shouldn't the ammonite structure be influenced like to a point where it doesn't fossilize because it has this like opening? Because essentially I believe like windows like this are happenstance of erosion in terms of how science would interpret this through a lens of fossilization, when, according to what I'm saying, high pressure water currents, they don't actually need to form entirely in the stone. They can actually extend outside of the boundary of the stone, so that would just be why these windows tend to happen, because they tend to grow to the boundary of the stone and sometimes beyond the boundary of the stone, and actually reach outside of the boundary of the stone, which then removes material and creates a window. So many incredible things that could be talked about for sure. Like, I really could and I could definitely write a book where I go through the details like I'm trying to do in a step-by-step manner. Like, okay, first of all, just know these are caused by water currents. That's what I'm proposing. That's what this book is about. If you're reading the book, it's because you're entertaining the possibilities and not just like naysaying. Because if you're naysaying, you're not gonna read the book. It's not complicated. So you like read it for the reason of fossilization, being offended that someone would say they're not fossils because you believe they're fossils, then you're probably gonna read like a first page and just like scoff and be done. So that's not really relevant. But if people are reading the book with the understanding that this is an alternative, like I don't try to present them as if this is like how they're understood. I specifically say a proposal is made. This book provides a focused analysis of the features of shallograms. I don't know if this wording is just like... Odds are if I rewrite any of this, it'll be quickly, and so it is what it is kind of thing. Like, obviously I gotta add detail and make it more formatted correctly, but like some of these things will probably make it through the gauntlets of not caring too much. And like I don't know if I want to refer to this book in essence, kind of thing, like that kind of thing. So be it. A proposal is made, like it's kind of scientific, it's kind of coming from the standpoint of it's a proposal rather than a understood reality that people are just like gonna have to deal with someday. But I still like kind of say that in short because it's true. Like, why does it matter? Because it's true. That's why. They're not fossils. That's why it matters. You know how much reality depends on these being interpreted as fossils? Our collective understanding of reality depends on these being interpreted as fossils so intensely. And even though no one even knows what they are, interpreting them as fossils, well, maybe not no one, but I'm exaggerating, but they're not well known. Even though they're not well known rocks, shallograms, even though just simply knowing that they're not fossils and that they are caused by current flows, it upends biology, obviously, because ammonites are not actually fossils. So that's a huge pillar of our understanding right there, just directly, because they're not fossils. So we got a lot to re-understand when we realize ammonites are not fossils. That alone is drastic in that, like, what's the history of life? Like, that's part of the history of life, ammonites. Like, and as soon as that, like, question of what even is a fossil then starts to emerge, then a lot of things start to be like, that's not a fossil either. That's not a fossil either. We misclassified a lot of things as fossils, and now that we can see those are not fossils, we can see that those other ones are also not fossils. That's like the degree of benefit that just knowing they're not fossils can offer in biology. But then it says, well, where are these high pressure water currents coming from? They clearly happened. Well, guess what? There's geological evidence of this across the entire Earth. second pillar, geology. Wait a minute, these are fractal structures that occur scale invariantly, so they are galaxies. If you want to see a galaxy close up, just look at an ammonite. If you want to see how one formed, look at some shallograms. They will provide answers. And in the same way, as above, so below, it's not just big things that they are the same as. They're the same as little things, such as atoms. So then we got physics, we got chemistry, we got biology, we got geology, we've got history, because it basically, well, where are these high pressure water currents happening? During the flood. So we got 5 things, which then branches into a bunch of religions and like interpretations of what history is. So we really, like, this stone matters, not just because it is the case that they're not fossils, but it really changes the understanding of everything that is believed in society to be true. It probably even influences our understanding of mathematics. I want to be surprised by depicting how math really functions in a way that it is hard to see other ways, like other places, just by doing math, let's say. Like the way limits are, the way infinity is, especially around those types of topics. 0, infinity, 1. That's why I gotta write this book, because they're incredible. I mean, they really are. They deserve to be understood by society, not just described as fossils. It's kind of ridiculous. When you know better, it's ridiculous. It's just due to, as I put here, Haltenar published his Atlas of Peculiar Galaxies, where he cataloged galaxies with anomalies. He wasn't like, let me find all the galaxies that fit modern interpretations of galaxies. Oh, look, there's one that looks the same as that one. It's just a spiral bar galaxy that looks just like that one. Okay, we've got many galaxies that look the same. So since there are many, and all these anomalous galaxies are few, we can just ignore the anomalies and say this is how galaxies work by looking at the ones that are like perfectly formed, but they don't have the peculiarities. So they're really kind of like ammonites in general. Ammonites tend to look like shells, and like I get why we think they're fossils. In general, ammonites look like fossils, even though there's anomalies with ammonites too that I've found in enough detail that they're just as clearly not fossils. It's just the real evidence is especially found in shallogram stones, because they're not removed from the matrix. The matrix holds the details better. The fine grainness of the process of the black shale being so fine grained makes it, like, compared to other matrices, more able to capture the nuances, just the perfect circumstances, but they're also peculiar because they're not normal. They're not just like your typical looking ammonite, they're peculiar. And that's why they're important, because they're anomalies. If we want to advance our understanding, we have to look at anomalies and try to understand them. We can't look, it's like trying to look at the Earth and being like, well, North America and Africa and South America were all together once. Yeah, that's obvious, but what about the Pacific? Well, that was just a huge ocean. No, it wasn't. The Earth expanded, though. It's just anomalously complex. It's anomalous. The Pacific Ocean itself, as like the entire structure, formation of things in the Pacific, is anomalous. And modern science builds its understanding generally from non-anomalies. It basically it builds a framework, says this is what we understand. These things that we see most clearly are the framework, and then everything else we'll try to fit in as best as we can. So like the Atlantic, we're building models off of plate tectonics is just pretty much an extension of some realizations that especially are around the Atlantic Ocean and its formation and the separation of those continents. But it's got nothing to do with any considerations in terms of what was really going on in the Pacific. That's kind of like we'll figure it out later topics. That plate tectonics, just that. Figure it out as we go and do our best, but then the theories are just accepting this is fact. Plate tectonics is so. And like going from there. So like any research paper, like any of these papers we looked at earlier, none of these are going to be like, none of these will raise an alarm and question plate tectonics. Okay, it doesn't even mention it, but it's in a framework of plate tectonics. Plate tectonics. That's a small paper, but like, let's say here maybe. Let's say plate tectonics. Just in the references, one of the authors has a textbook called Plate Tectonics and Crustal Evolution, and a plate tectonics and how the Earth works. But like if we go to the up here, let's say there's no like question. Are we in a plate tectonics framework? Is that what we're analyzing this through? Are we sure this data fits it? It's just fact according to science, so it doesn't need to be looked at. And yet, that's the problem. It is not true. So all this new evidence gets to just be put into the preconceived notion model of what we believe, what has reached consensus, what has been forced into consensus, whatever exactly mechanism by which it happened, just shoved on in there. And it looks like the data shows plate tectonics is true. But like same thing for ammonites. If you look at technical papers on ammonites, you're not gonna find a technical paper that's like, is this a fossil? Let's say, are ammonites fossils? Extinction of ammonites. Just assume they were a living being. Role of ammonites in the marine food web. It never existed. These are the results of current flows. So what would they have to do with an actual food web? Mode of life and habitat of this type of ammonite. The feeding habits of ammonites. Biostratigraphy is a tool for dating, which is another point in the direction of geological processes, is that it's used for biostratigraphy. Stratigraphy, which is the dating of geological layers, pretty much. Ammonite biostratigraphy, time from fossils. Fossils are geological clocks. Ammonite fossil, an ammonite trapped in Burmese amber. Fossils. History of the classification of Mesozoic ammonites. Let's see if this even acknowledges there was a time that we didn't think there were fossils. Let's see. First subdivided at generic level on the basis of shell coiling, heteromorphs or uncoiled shells being separated after 1799 from the normally coiled shells. So basically, it starts immediately. Step 1. Ammonites are fossils. What did we do after we called them fossils? They were subdivided at generic level on the basis of shell coiling, blah, 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 blah. No even discussion, at least that we saw there, that these there was a time these were not understood to be fossils, and here are some alternatives that were passed around at the time. Just straight up, these are fossils. Now we're writing a technical paper. It's like a sneaky way that even though we adhere to the scientific method, once something gets in that's false, it's no longer looked at from the same microscope. It's just kind of taken for granted at that point. And the more it works its way in, the more it's just established and doesn't actually require any reinspection, so it doesn't even get inspected. So basically, even a paper talking about ammonites, the history of classification, doesn't even acknowledge there was a time they were not ammonites. They were not fossil. They were not considered fossils, that is. There once was a time when we didn't know what these were. New approach for the determination of ammonite and nonylid habitats. So, this is the degree, no offense guys that are participating in this, but this is the degree of absurdity that we're at, is that we are deciphering how these creatures that never were lived. Doesn't even make sense. They never were, dudes. Think of how much energy is spent thinking of ways in which these creatures lived when they never lived. They never were. They didn't exist. They formed in current flows. I know. It sounds ridiculous, but it's the reality of the situation. Oh my god. Yeah, the flood too. Maybe God is the ultimate troll. Straight trolling. Straight trolling. Oh. Damn. Okay. I'm just babbling. I'll see you guys in the next one. Thanks for hanging out. Peace out. Till then.